Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the next question. This question is based on the topic of continuity. It says let fx equal to x into GIF of x upon 2 for x greater than minus 10 and less than 10, where GIF stands for the greatest integer function, then the number of points of discontinuity of f is equal to. Now students, in this question, we have to find the total number of points of discontinuity for the function f of x. Now f of x is x into GIF of x upon 2. X is a polynomial function which is always continuous, and GIF of x upon 2 will become discontinuous whenever x upon 2 becomes an integer. Now x is given to us lying between minus 10 to 10. So this means x upon 2 will lie between minus 5 to 5. Now students, between minus 5 and 5, there are 9 integers: minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. So that means these are the susceptible points at which the function f of x may become discontinuous. Now students, we will define the function f of x for different intervals of x. Only then we will be able to confirm whether f of x is discontinuous at all of these points or not. Now let us move further. Now students, I am defining the function f of x in different intervals of x. As x is greater than minus 10 and less than 10, so I am dividing this big interval into subintervals. The first subinterval is when x is greater than minus 10 and less than minus 8. For this subinterval, x upon 2 will lie between minus 5 and minus 4. That means GIF of x upon 2 will become equal to minus 5, or f of x becomes equal to minus 5x for this subinterval. Now the second subinterval is when x is greater than or equal to minus 8 and less than minus 6. In this subinterval, f of x becomes equal to minus 4x. Now when x is greater than or equal to minus 6 and less than minus 4, then f of x becomes equal to minus 3x. When x is greater than or equal to minus 4 and less than minus 2, then f of x becomes equal to minus 2x. When x is greater than or equal to minus 2 and less than 0, then f of x becomes equal to minus x. When x is greater than or equal to 0 and less than 2, then f of x is just equal to 0. Now when x is greater than or equal to 2 and less than 4, then f of x is equal to x. When x is greater than or equal to 4 and less than 6, then f of x is equal to 2x. When x is greater than or equal to 6 and less than 8, then f of x is equal to 3x. And lastly, when x is greater than or equal to 8 and less than 10, then f of x is equal to 4x. Now students, in the open interval minus 10 to 10, between any two consecutive even integers, the function f of x is a polynomial function. So obviously it will be a continuous function. But at all those even integers where it is changing its definition, that is at x equal to -8, -6, -4, -2, 0, 2, 4, 6 and 8, the function f of x may become discontinuous. Now since there are 9 such points, so it will be difficult to check the continuity of the function f of x at all of these points. So to make it easier, I will check the continuity of the function at x equal to 2k, because we have to check the continuity at even integers. And here k refers to any element of the set containing the numbers -4, -3, -2, -1, 0, 1, 2, 3 and 4. Right? Now students, we move further. Now students, to check the continuity of the function f of x at x equal to 2k, we will have to find its left hand limit at x equal to 2k as well as its right hand limit at x equal to 2k. Now left hand limit for the function f of x at x equal to 2k becomes limit fx x tending to 2k minus. Now to find this limit, I am replacing x by 2k minus h in the function f of x, where h is approaching 0. Now f of x is x into GIF of x upon 2. So it becomes equal to 2k minus h into GIF of 2k minus h whole divided upon 2. Now students, this further becomes equal to limit h tending to 0, 2k minus h into GIF of k minus h upon 2. Now k minus h upon 2 is slightly smaller than k. That means GIF of k minus h upon 2 is equal to k minus 1. So clearly LHL or left hand limit becomes equal to 2k into inside the bracket k minus 1. Now students, we find the right hand limit at x equal to 2k for the function f of x. It becomes limit fx x tending to 2k plus. Now we will replace x by 2k plus h, where h is approaching to 0. Now students, f of x becomes 2k plus h into GIF of 2k plus h whole divided upon 2. Now this further becomes equal to limit h tending to 0, 2k plus h into GIF of k plus h by 2. Now k plus h upon 2 is slightly greater than k. So that means GIF of k plus h upon 2 will become equal to k. Now students, we move further. Now students, the value of the right hand limit at x equal to 2k becomes equal to 2k into k. Now for the function f of x to become continuous at x equal to 2k, the first condition is that limit at x equal to 2k for the function f of x must exist. And for that purpose, left hand limit at x equal to 2k must be equal to right hand limit at x equal to 2k. And for this purpose, 2k into inside the bracket k minus 1 must be equal to 2k into k. So this implies 2k comes common. Inside the bracket we get k minus 1 minus k, and this must be equal to 0. Now from here we get 2k equal to 0 or k equal to 0. So this means the continuity for the function f of x may be possible only for k equal to 0. At all other values of k, the function f of x is clearly discontinuous. Now students, we will find the value of the function f of x at x equal to 0. From our previous discussion, we know that f of 0 is equal to 0. So that means limit fx x tending to 0 minus is equal to limit fx x tending to 0 plus is further equal to f of 0. So clearly the function f of x is continuous at x equal to 0. That means there are 9 minus 1 or 8 points of discontinuity for the function f of x. In the open interval minus 10 to 10. Now students, in my next video, I will discuss the solution of another question from previous year questions of JEE Main or JEE Advanced. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.